my friends. Today we're talking about periodic table organization. That is how the periodic table is actually organized. So let's take a look at it. The first thing to note is that the periodic table will help you organize your chemistry knowledge. It's really important. If you understand how to properly read the periodic table, you will basically have a key to understanding chemistry. It's amazing. So the table are arranged in two things: groups or columns. Those are the things that go up and down. So when you're looking at the periodic table, the up and down are groups or columns. These are known as families. Periods or rows go across. So if you're using your hands and you make your hands into a T, so make a T with your hands. When you're the top part of the T that's crossing the T, that looks like your periods or your rows. The bottom part of the T that is going up and down, that are your groups and columns. So when in doubt, make your T and realize the top is groups. Sorry, the tops are rows and the bottom is groups or columns. These are also known as families. So the important things about groups and families is that they are nestled together like a family that have similar properties. There's a total of 18 groups. 8 of them are the representative elements. That's columns 1, 2, 13, 14, 15, 16, 17, and 18. And columns 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, those are your transition metals. And they have similar properties. That's why they're together. Versus the rows that go across, those are your periods, and is in the periodicity or the repetition of the periodic table. And they have elements that have properties that repeat. There are 7 periods. So if you count starting at hydrogen and go down that column, there'll be 7 elements, and there are 7 rows, and across there are 18 total groups or columns. So let's take a look here. Please ignore the A's. I really like this picture, but the A's are from the old way of organizing things versus, how they do 1, 2, 13, 14, 15, 16, 17, and 18 now. But you can see that these are a nice way of organizing your groups and families. Periods, on the other hand, they go across. Look, I know this doesn't have all 7 on them because I couldn't find a really pretty one, but it is your period. They go across. So they are named pretty much the first element in the group followed by the word family. There's only 2 exceptions to that. That is the alkali metals, that's column 1, and alkaline earth metals, which is column 2. They're called alkali metals and alkaline earth metals. Both the alkali and alkaline earth metals are really chemically reactive, with the alkali being the most reactive of the 2 because it has 1 valence electron, so therefore it very easily wants to give up its valence electron in order to get to 8 valence electrons. More on that later. 13, if you look at the top of column 13, the first element is boron, therefore it's called the boron family. The first element in column 14 is carbon, therefore it's called the carbon family. First element in column 15 is nitrogen, therefore it's called the nitrogen family. First element in column 16 is oxygen, therefore it's the oxygen family. For column 17, first element is the fluorine family, so you could call it the fluorine family, but they're very commonly called the halogens because halogen means salt maker, and anything mixed with column 17 is a salt. And remember, please remember, not all salts are edible. They aren't all those really beautiful pink Himalayan salts. A lot of salts could be deadly, and that would be very bad. And number 18, the first element is helium, so therefore it could be called the helium family or the noble gases. And if you remember noble gases as being the highest number because they're nobility, and also because they're above everything else because they are completely inert and don't react. And these right here, 1, 2, 13, 14, 15, 16, 17, and 18, these are considered your representative elements. Versus 3 through 12, which are your transition metals. So you have the scandium family for column 3, titanium family column 4, 5 is the vanadium family, 6 chromium, 7 manganese, 8 iron, 9 cobalt, 10 nickel, 11 copper, and 12 is zinc. If you remember, all parts of the zinc family have fully filled orbitals that'll be helpful in the future. Also remember that these are your transition metals, and again, how you name them is the first element of the column and then the word family. Here is a beautiful periodic table. I think some of it may be slightly cut off, and I apologize. I'm doing the best I can learning this lovely new program. But over here is your alkali metals, then your alkaline earth or alkali earth, but we call them alkaline earths. Here's the transition metals. Down here are your rare earths and radioactives. Over here, boron down to, tellurium, there's kind of the staircase of your semi-metals. That means they're kind of like metals, and they have some like metals and some like non-metals. Aluminum through polonium, that makes this kind of L of other metals, and then carbon through astatine kind of fills out the non-metals. And all the way over here on the very right-hand side are your noble gases. Hydrogen's way up here. It's in its own category because it's kind of neither metal nor non-metal. Okay. I know we haven't quite done electron configurations yet, and we will be re-referencing this, but it's good to know that this is a good periodic table to reference for the electron configurations. It's based on both column number and principal quantum number. And the S, P, D, and F block elements. So I'm going to switch back for a second. So look at the first two columns. That's the alkaline and alkaline earth metals. That is the S block, and that also includes helium because helium only has 2 electrons, 2 electron potential, so it technically is the S block, even though it's already all the way over into the noble gases. The transition metals, that's columns 3 through 12, that is your D block. Your the rest of your representative elements, that's columns 13 through 18, that is your P block with the exception of helium. And then your inner transition metals, that is what jumps down here. That is your F block. And here's some information. We will be discussing this later, but it's good to know that the S orbital holds a maximum of 2 electrons because it spans 2 groups. You add 1 electron for each group. So when you're going left to right, like you're reading a book, for each column you include on that level of that electron, of that element, you're adding a single electron. The p orbital holds a maximum of 6 electrons because it spans 6 groups. And if you remember that 8 is great, if you add the s block and the p block, s plus 2 plus 6 equals 8. So that's how you get that 8 is great number. The d block holds 10 groups, therefore it holds 10 electrons. And is very rarely counted towards your total electron your total electron count for valence electrons. Pretty much your valence electrons will always be your S and P block, and then F contains the inner transition metals. So if we're thinking about this in terms of your valence electrons, you're looking at counting up your S and P blocks. If you are thinking about your just total electrons, and you're including S, P, D, and F. F is your inner transition metals. That's 14 columns long, therefore it spans 14 groups. Therefore, it has a potential of 14 valence electrons. And the principal energy levels is the energy level denoted by the principal quantum number n. And you're like, oh my goodness, I'll never be able to remember this. This is so difficult. And it is okay if you think about it like this. For S and P, your principal quantum number are always 1, 2, 3, 4, 5, 6, 7, whatever your row number is. Same with D and F. That's your principal quantum number, is your row number. But for D and F, D goes back 1, so it's principal quantum number minus 1, and F goes back 2 as your principal quantum number minus 2. So I'm going to switch back 2, and if you look where D starts here with scandium, that's number 21. It's in the fourth column, but it's 3D because the principal quantum numbers have gone back 1. And if you look down here for, number 58, right after the lanthanum, down in the lanthanide series, it jumps down from the 6th column, but it's 4F because it goes back 2. And that is about the organization and basic information of the periodic table.